Okay, so we're going to take a look at our data one more time. We're going to take a look at it with a little bit more detail this time around. So before we do that, just once again, this quick reminder about what inferential statistics is doing and the importance of inferential statistics as well. So inferential statistics, all it tells you, its bottom goal, its final destination, is to just tell you whether a difference that you see between conditions, is that a real difference, that is a real psychological difference, or have you just created a difference due to chance? Okay, so if you want to put this in terms of the kind of classic coin flip situation, if you were to take a coin that was fair and you were to flip it 100 times, you would expect that 50 times it would land heads, 50 times it would land tails. But what if 51 times it landed heads and 49 times it landed tails? Would you then say, oh, that's an unfair coin? Probably not. You would probably say, that's just due to chance, right? We got a 2 flip difference, it could happen. On the other hand, if you flipped it 100 times and it came up heads 90 times and tails only 10 times, then you would say, that's not random, that's not chance. Something's going on here, that's an unfair coin. So remember that, remember the girls trying out for the basketball team where you're trying to find out which of these two is the better player. If you play them head to head and this girl beats this girl 20-1, that difference is so big, that is very unlikely due to chance, to random factors, to lucky bounces. This is probably due to the fact that this girl actually is a better basketball player. So inferential statistics will take a look at the size of the difference between two groups when it's considering whether the difference is real or whether it's due to chance. If that was the result after one game of one-on-one, then inferential statistics would take a look at this and it would say this result is probably due to chance. She's probably no better than this girl over here. That is a small difference, is probably due to chance. And this is very important to remember because sometimes when you're reading the data, when you're interpreting data, your human mind has been so trained to know that this number is bigger than this number that it's kind of hard to retrain it to say that, oh no, these numbers are really the same. It's just a difference due to chance. But that's what inferential statistics tells us, and that's what in the end we're going to have to communicate to our readers when we write our report. And then lastly, inferential statistics takes into account the regularity of the results. So if there's not a lot of variation, even if the results or the difference is very small, if it's highly reliable, inferential statistics will once again say she's the better player than her. This difference is small, but it's so regular that it can't possibly be due to chance. So that's all inferential statistics is all about. So now that we know that, let's take a closer look at our data. So we're going to get into the idea of main effects, and we're going to get into the idea of interactions in a little bit. I just want to touch on it right now. So these are the results from the in-class experiment. And what we got here on the y-axis is percent recall. This is the percentage of words that you recalled during the recall session. So it's out of 100. If you recalled 100% of the words, that means you recalled everything. If you recalled 0% of the words, that means that either your page was blank or you didn't remember any of the words. So here we have the effect of item type, and we have the effect of item type alone. So that's what a main effect is. It's the effect of each variable that you have in your experiment isolated, alone. So we had two different types of items. We had correct items, words that were actually on the list. We had critical items, words that were not on the list, right? These are the false memories. And we also had another variable. We had groups. We had, were you in a group of 3? Were you in a group of 2? Or were you doing this individually? We had 3 different sized groups in this experiment. In a main effect like this, what it does is it takes the data from all 3 groups and combines it into one score. So this bar here contains the individuals, the pairs, and the groups of 3, and their performance on correct words. This bar here contains individuals, pairs, and groups of 3, and how many false words, false memories did they recall. So this is the data right here, and to my human eye, I would take a look at this and I would say that's a real difference. Our minds are actually truly better at recalling correct information than we are at making false memories. So does everybody kind of agree with that? It seems reasonable? Okay, so it is actually reasonable, and this is one of the instances where what we kind of think matches up with what inferential statistics tells us. So in these graphs in your notes, the green connections, those means groups that are different, statistically different. Inferential statistics says this is different. So we are actually better, our minds are actually better at recalling correct information than we are recalling critical information. So that's nice to know, right? It's nice to know that most of our memories are true memories, and we're not walking around with, tons and tons of false memories. However, notice just how high those false memories were, just under 40%. So just about 2.5 words per 6 false memories were recalled by people in this experiment. So this experiment was specifically designed to create these false memories, but it's sobering to know that so many false words were recalled in this particular experiment. All right, so I talked about the main effect for item type. This is the main effect for group size. So this is the percent recall for people working alone, percent recall for people working in pairs, percent recall for people working in groups of 3. And these bars make a little bit less sense because each of these bars is a combination of the words you recalled correctly and your false memories. So this is almost just how much recollection did you have, how much memory did you have, whether it was right or whether it was false, what was the total amount of things that you remembered. And as you can see, there doesn't seem to be a lot of difference between how much singles, pairs, or groups of 3 recalled, and in reality, there isn't. So inferential statistics told us that these differences, these small little differences, so you can see just a little small difference there between pairs and just a small difference between pairs and triples, inferential statistics told us that is due to chance. Those 3 groups are actually all exactly the same, which kind of seems a little weird because you would expect maybe pairs and groups of 3 to recall more than singles did. But in this main effect, we see that that difference is actually not significant. It's actually just due to chance. Now, I mentioned that it seems that way because the real story, the final story, actually isn't that case. The final story comes out in the interaction. So whenever you have, and we're going to spend a lot of time on interaction, whenever you have 2 variables in an experiment, you have the potential for those variables to interact, right? And an interaction, one of the easiest ways to understand the idea behind an interaction is to think of drug interactions. So if you've ever had a prescription medicine that was prescribed to you, usually your prescription medicine will say something like, do not take this with alcohol. Why don't you want to take it with alcohol? Because of these drug interactions. So the prescription medicine on its own has the effect of curing your disease. Alcohol on its own has the effect of lowering your inhibitions. But the prescribed medicine with alcohol has the effect of sending you to the hospital, right? Not curing your disease, destroying your liver. So that's an interaction because there's nothing to suggest that curing your disease, that's great. Lowering your inhibitions, that's great. Why wouldn't I take the 2 together? I'd have a cured disease and I would have lowered inhibitions. No, you don't, because the 2 of them interact and that is why we run these two variables together. So much like that drug interaction, we're looking for pair versus type of memory interactions, and that actually comes out here. So once again, we got percent recall. Once again, we got the group sizes. We got people working individually, people working in pairs, people working in groups of 3. And then you can see up here, the blue bars, these are the correct words, correctly recalled words. The red bars here, these are the false memories. And the statistics, inferential statistics told us that for correct words, we actually get that 2 heads is better than 1 and 3 heads is better than 2 effect. So groups of 3 remembered the most correct words, and that was followed by groups of 2. And groups of 2 were better than groups of 1. So if we were looking to answer the question, are groups better at remembering words? Are 2 heads better than 1? We would have come up with the prediction that pairs should recall more than singles, and lo and behold, that's what we found. And then if you take a look at the critical words, if there was no interaction, then it should follow the same pattern. But it doesn't. It actually looks like it follows the opposite pattern. It looks like these differences should be significant. But as we saw last time, inferential statistics says, no, those bars are actually no different from each other. These bars here do not indicate a real difference. The only reason that they have these different heights is due to chance. So this is one of the reasons why statistics is so important, because to my mind, that looks like groups of 3 have fewer false memories than pairs. Pairs have fewer false memories than singles. But that's just taking into account the size of the difference, not the reliability. You take both of those into account, and it turns out that single individuals actually recall just as many false words as pairs and just as many false words as groups of 3. All right, so that's one half of the results. Any questions about that? No, does it all make sense? The picture kind of forming of what happened? All right. So hopefully you remember in the experiment, not only did you write down the words you could remember, but you also rated them in terms of how confident you were in those recollections. So let's take a look at that confidence. So first off, we'll once again start with item type. We got correct words over here, words that were on the list. We got critical words over here. These were the false memories. And we got confidence over here. So confidence can go all the way to a maximum of 4. That was the maximum amount of confidence. Minimum was a confidence level of 1. And as you can see, once again, thankfully, we are significantly more confident about our correct words than we are about our critical words. So we are more confident in the words that we remembered and that were true memories, and our false memories had less confidence. But once again, even though this is significantly different, notice that for our true memories, we're looking at like 3.8, 3.9. For our false memories, we're like at a 3.2. So it's not like you're really unconfident about your false memories. You're just slightly less confident about your false memories. And you can't get to 3.2 without 20% of individuals at least saying, yeah, I'm 4 out of 4 on this. I'm 100% confident for this memory. So critical false memories actually had pretty high confidence. Thankfully, though, our minds are working well, not as confident as our correct words. All right, what about our groups? How did our groups do? So now we got single individuals. And again, these are a little bit hard to interpret because this combines correct words and critical items. This combines correct words and false items for pairs. This combines correct words and false items for groups of 3. But let's just make the analysis complete. As it turns out, once again, I would take a look at this visually and I would say singles probably going to be different than pairs and groups of 3. And inferential statistics says, yes, they are. So singles actually do have less confidence for their memories in general than do pairs and groups of 3. And pairs and groups of 3, they do not differ between each other. So it seems like the key factor here is whether or not you're working alone or whether you're working in a group. You're working alone, lower confidence for your memories. You're working in a group, higher confidence for your memories. So far, so good? All right, last result. So this is one of the most intriguing ones. I think this is one of the biggest results here. So we have, once again, singles, pairs, and groups of 3. And we have correct items in the blue, and we got critical items in the red. So words that were on the list, and these are the false memories, those 6 words that were not on the list. And the first thing we'll see is that inferential statistics has shown us that for the correct words, individuals, pairs, and groups of 3 have the same confidence. So when they're correct, individuals are not lower in confidence than any of the groups. When they're correctly recalling things, individuals have just as much confidence as do groups. However, for the false memories, for the incorrectly recalled information, singles actually have significantly, truly less confidence than do either pairs or groups of 3. So if you are remembering things in a group and you falsely remember things in a group, you will attribute way more confidence to that false memory than you would if you were recalling things alone. And it doesn't matter what the size of the group is, because pairs and groups of 3, they actually have the same amount of confidence for their false memories. All right, so everybody kind of got the picture of what happened in the experiment? Any questions on what occurred? All right, so the last thing I'll mention today, and then we'll wrap it up, is so far with this data, it's very interesting, it's very cool. I like it, I like numbers, I like stats. But if this was all that it is, once again, it's kind of a little parlor trick, right? Once again, if this is all that it is, I could say things like, well, if I put you together in pairs, you're more confident about your wrong answers, haha, ta-da, right? It's like almost like a horrible magic trick that you wouldn't want to watch, right? So that's if it stays here. The key to psychology, the key to science, the key to experimental psychology, the importance of it is what does it mean beyond the lab? So what I want you to do as we go through this is try to think about situations in the world where people are trying to remember things either individually or trying to remember things in groups. And based on this data that we have, based on these differences that we've seen, is it a good idea to do it that way? Or is it dangerous to do it that way? So for example, in the jury system, right? We have 12-person juries trying to make decisions and remember all these details about what they heard in a court case. Does this say that that's a good idea? Or does it leave it open to potential for miscarriages of justice because of false memories creeping in? If you take a look at on social media, the rise of conspiracy theories, the rise of pseudoscience, right? That didn't happen prior to social media. Can we explain what's going on in terms of what we have here, in terms of the higher confidence, for groups? If you were a therapist and you were dealing with people who were trying to recover memories from their childhood, right? Maybe they experienced a traumatic event and they were trying to recover memories from their childhood. Would it be a good idea to do this therapy in a group setting? Or would that be an incredibly horrible idea to do it in a group setting based, again, on this data? So if you think about it in that way, if you think about it in terms of that impact, the impact of somebody getting sentenced to 20 years in prison versus being set free, the impact of conspiracy theories and violence against minorities and people not vaccinating their children and flat earthers and climate denial, climate change denial. If you look at it in terms of people receiving therapy that could either help their lives or destroy their families, if you look at it in that terms, then this goes from that little ta-da trick to an incredibly important piece of information to help us help people and make the best out of their lives. So as we go through this course, this is the data that we're going to be working with. This is the experiment that we're going to write up. We're going to learn how to put all those pieces together. But continually think about this because it'll come up in the discussion. As you see, just in your daily lives, if you see a news piece, if you hear a story from your friends, and it has something to do with group memory, group cognition, just take a moment and say to yourself, what might my experiment have said about that group theory? Is that what we should be doing based on the data that we ran in this experiment? All right, are there any final questions, thoughts, comments, anything before we wrap it up? All right, so that is it for today.